To conclude our discussion of the anti-de Sitter space-time, let me just introduce Poincare patch and Poincare coordinates of the anti-de Sitter space-time. Well, to remind you, anti-de Sitter space-time is given by this equation, minus x0 squared plus sum of j from 1 to d minus 1 x j squared minus x d squared equal to minus 1 over h squared. And it is embedded into the so-called, into the space which has signature plus, minus, 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 and plus. Now, one can solve this equation as follows by giving x0 equal to z over 2, 1 plus 1 over z squared times 1 over h squared minus x mu times x mu, and z here is greater than 0, greater or equal to 0. x1 is z over 2, 1 minus 1 over z squared, 1 over h squared plus x mu times x mu, and x mu, big X, x mu is equal to x mu over h, where mu is ranging from 2 to d. And one last point is that x mu times x mu is actually eta mu nu times x mu times x nu, but eta mu nu, it has a signature which is a bit different from the one that we're using. It has pluses, all pluses, and one minus sign. All pluses and one minus sign. We remember that before we were using Minkowskian metric where one minus and the rest, one plus and the rest are minuses. Here it's a bit different. So for z greater than 0, one can see from these expressions that x0 minus x1 is equal 1 over hz squared, and and it is actually greater than 0. So these coordinates, unlike the previous ones, which cover entire anti-de Sitter space, these coordinates cover only half of it, given by this condition. And in fact, if one uses these coordinates, the induced metric on the anti-de Sitter space is just ds squared equal to 1 over hz squared, dz squared plus dx mu and dx mu, where which is very similar to the metric in expanding and contracting patches. Remember that we had like this, h eta plus minus squared, d eta plus minus squared, minus dx squared. But here, the important crucial difference with respect to this de Sitter metric, here eta is time, but here z is space-like. Time in anti-de Sitter space is among these coordinates. It's like dx vector squared minus dt squared. So time is this. So the anti-de Sitter space-time metric is stationary, while it's actually even static, while the de Sitter space-time metric is time-dependent. That is a crucial difference between these two spaces. Actually, these coordinates, according to this condition, one can easily see what half of the entire, in case of 2 dimensions, one can see easily what part of the entire anti-de Sitter space it covers. It's just like this half of the anti-de Sitter space. In higher dimensions than 2, it is a bit harder to see, but it still covers half of the entire anti-de Sitter spacetime. Well, this ends up our discussion of the anti-de Sitter space and the spaces of constant positive and negative curvature, and actually ends up our introduction to general theory of relativity. And so that's the end of the story. Good luck. Good luck at the exams. Good luck at the study of this course. I hope you will enjoy learning this subject and use it in your further studies of basics of theoretical physics, quantum field theory, gravity, etc., and etc.